So everything you say from now on, Bruce, will be taped.
Next time you go in for a job interview, that'll come up.
So for the last 6 months,
They sell the cars every morning. Oh, you know, probably just a fundraising gimmick, right?
All right.
I 2% of it.
They just want to cut of all this spaghetti.
How does that look to everybody? Good? Probably the how about that? Better?
That's good. Yeah.
Yeah. All right. So open up Xcode. We're going to go to new, say project. And choose single view application. Huh? I know it's got a cool game logo, but oh, whoops. Dave wants me to share my screen. Why don't you just take yourself off mute and ask me yourself, Dave? Just kidding. All right. How am I sharing? Screen 2. Share all of screen 2. There we go. All right. All right, is everybody there? So I got Xcode open. And everybody's clicked on new project. And we're out this screen. Okay, so I'm gonna hit next. You can call it whatever you want. I'm gonna call mine just regular hex. Bundle or organization identifier, I used tv.shout. What Scott did. So organization name, whatever. I don't know. Mine defaults to Grant Robinson. You can put whatever you want there. Language. I'm doing all the examples in Objective-C. If you want to embark out on Swift on your own, be my guest. But
can we mix them in the same project?
You can if you want to. Yeah.
So I could start on Objective-C and then try and do it.
Yeah, I mean, what you would probably want to do is you probably want to create a new project at that point, because you wouldn't want to write the same classes in one in Objective-C, one in Swift, unless you wanted to call them different names or something. So device is universal. We're not going to use core data for right now, and even if we did, we don't want to use the setup that they're going to give us. Include unit tests, no. Include UI tests, no. Hit next. Oops. My pointer was on the wrong place. Hit next. There we go.
You click on that.
I clicked on the thing over here. All right, and then choose a place to stick it.
Look at that. Create Git repository on my Mac right there. Just do it. Git.
That's not,
Dave is going to do that for us.
that's not cool that my button's off the screen, though.
Do that thing you showed me. How to do, like,
I don't think that's an overscan problem. I think it's just 720p is just too small. If there was an overscan, you'd see it around the edges.
Yeah.
So anyway, okay. Well, so whatever folder you choose, then it's going to create a folder named Hex or whatever you named it inside there, and then inside there it's going to stick all your stuff. All right. So now we have this default project. And I'm going to be switching back and forth between this, and I need to go open. Open. So also stole another thing from Scott's playbook, which is I have a couple of different revisions here. So we're going to open this version 1. The first thing we're going to, so I thought this was going to be a lot easier to put together, but Android and iOS are just so different. The few things that I started to do the same way that Android was doing them, it didn't make, like, I probably could have done it that way, but it would have been like, square peg round hole, exactly. So, so inside there, we're going to create a couple folders. So go highlight here. We're going to create a folder, or a group, sorry, do a new group and call it Hex Game or something. And say new group, and we're going to create another group called Engine. And we're going to go in here, we're going to right click on the view controller part, say refactor. I'm going to rename this. I'm going to rename this to, okay, so just go put your cursor over the view controller part and then right click, and then you should get a menu. One of the things in there should say refactor.
View controller.h.
So yeah,
Cursor over the view
put your cursor over the view controller part, and then right click. Should see cut, copy, paste, find blah 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 blah, and then refactor right there.
How do you right click?
Control click or 2 fingers in the bottom right corner is how I have mine set up. So, and then you hit rename. We're going to rename this to Hex Game View Controller. Hit preview. For some reason, it's not actually showing me what it's going to do, and I know what other is because I was on the wrong thing.
Wow, your computer is so much faster than mine. Still going.
All right, so
Anyway, so this shows what it's going to do. It's going to rename View Controller to Hex Game View Controller. It's going to rename the .m file as well. It's going to rename the symbols. Let's go into our storyboard, and it's going to rename our View Controller in there.
I only get a menu like this.
That's because you're clicking on it over here.
Still
You need to
isn't
click
done.
on it over
It's
here.
in mine. Oh, okay. So
Highlight it right there, and then
mine's taking forever too.
and then reclick.
All right, back to rename.
Just finished. No, it didn't.
Where am I renaming it to?
So Hex Game View Controller. I mean, you can leave it View Controller if you want. I just rename it because View Controller is very generic, and
There are lots of view controllers.
yeah,
It gets confusing.
at some point we're going to have more than one view controller, and so you'll want to be able to differentiate which is the main game view controller versus the other ones, right?
Mine finished, but it didn't show me any files like yours did.
So click on the one in the middle, and it'll show you the files it's going to rename. So anyway, this is just a little. This is just to show you if you ever want to refactor, this is how you do it, and it will show you what it's going to do. And if you ever decide that you don't want to make a change, like say I had something else and I don't want to do it, then I click on here and say do this change, whatever. That is happens to find something that shouldn't refactor. Anyway, then you just hit save. We now have our Hex Game View Controller. So I'm going to take that file and its associated, the .h and .m, I'm going to move those up under Hex Game.
These directories, these groups are arbitrary.
These groups are arbitrary. You can name them whatever you want. It's just a way to organize your files. So it doesn't actually, because we didn't create a folder reference, this doesn't actually represent a folder on the file system. It's just a logical grouping inside the editor. So, and oh yeah, that's the other thing we're going to do. Okay, so then we're going to let's go up and open our main storyboard. as you can see in here, which you can't really see very well because it's... So with iOS 7, they switched over this thing where you're doing size classes. Sometimes it's helpful to change it from inferred size class to an actual something we know about. In this case, we're going to choose an iPhone 4-inch.
Where did you get
So
that?
you clicked on the main.
So I click on Hex Game View Controller here, and then over on the right-hand side, we've got these little panels. We want to click on this one that kind of looks like a pencil or whatever, the Attributes Inspector. And then it says Simulated Metrics. This is telling you, hey, what's this going to look like on the screen? You can say, okay, well, it's actually going to be a landscape view. It's going to look like this, or it's going to be, inferred. Inferred is almost always portrait, right? You can also choose a simulated size. If you choose inferred, then it's going to do the any width, any height size class and say, this thing's 600 by 600, even though it's never going to be that at runtime on any device you're going to ever have, right? It's either going to be 320 by 480 or 320 by 568 or 375 by whatever the iPhone 4 is or the 5.5 inch or whatever, right? So
Pick iPhone 4.
So I just picked iPhone 4 because it's a little bit better size for us. All right, so, and then we're going to put a couple of things inside of here. So scroll down and so below there we have our little, these are some of our other things. We've got code snippet library, the file template library. We want the object library, right? So go to the object library, scroll down until you get to scroll view. And we're going to take a scroll view. We're going to drag it over here onto our main view, up into the top right corner.
You're not alphabetical.
They're not.
Yeah, there's a search bar at the bottom.
Yeah, you can search for it if you want, or just scroll down. Yeah, they're not alphabetical. They're actually by like grouping. So the view controllers are first, and then the controls, and then the views.
So where in the
specialized
grouping
view.
scroll view? I don't see it.
It's below.
It's like halfway down.
So you're going to go past all the controls like switches and activities, and then you'll get into like the horizontal stack views, table views, image views, collection views, and then there's text view, scroll view.
All right.
Right.
Drop it in the square.
Yeah. Drop it in there on the top right corner, and then we're going to extend it out. You want it to fill up the entire view, right?
Mine didn't. To get it to do that.
You're going to have to drag. So grab in the top, bottom right corner and drag it until it fills the entire view. Once you've done that, then we're going to go over here to the size inspector. Okay. We're just going over here so that we can see what's going to happen when we start adding some constraints. Okay, so we still have our scroll view selected over here. We're going to go down here to the auto layout stuff. We're going to get rid of this constraints to margin thing. And we're going to click on this one, this one, this one, and this one.
I remember this. Correctly.
What this is doing is it's saying, what Apple wants you to do now is what they call design with intent. So rather than doing necessarily a pixel perfect layout, you design, hey, this is stretchable, this is not stretchable, this should be pinned here, this thing can grow to fill, and that way you end up with a user interface that, like Matt just said, even though we spent almost zero time on the actual iPad version of FlashVote, when you stick it on your iPad mini, it looks really nice because we designed this entire thing, even though it's painful in places, with intent, right? And I would ask you, hey, ask Amy, what should grow and shrink here? And so the iPad version looks pretty good, even though we spent probably 2 hours, maybe 3 hours total, this entire project on.
So we're adding these 4 constraints.
So these 4 constraints are saying this scroll view is going to take up the entire rest. Pin the top to the top of the super view, pin the left to the left of the super view, the right to the right of the super view, and the bottom to the bottom. So you end up with a view that no matter how big or small our actual main view gets, the scroll view is going to grow with it. Okay. Now, it's not going to like, initially it's not going to like what we just did once we do the next thing. So we'll take care of that in a second here. So now we're going to drag another view, and we're going to drop it inside of our scroll view.
What's the name of the new one?
Just a plain old view. It's down very close to the bottom.
You control it?
Second at the bottom.
Nope, just a regular view.
Stick it on top of the scroll view.
Yeah, you're gonna stick. Well, yeah, just drop it on top of the scroll view, which will stick it inside of there. And then we're gonna do the same thing we just did with the scroll view with this. We're gonna take it and we're gonna drag it so that it fills up. This is really awkward on this size screen.
You want to do the same thing, make it fill?
And so this one, and then once we've dragged it so it's the full thing, we're gonna go do the same thing inside of here. Now here's something funky about scroll views. So scroll views, conceptually, they have the views contained inside of theirs are on a plane that stretches from infinity to infinity in both directions. Okay, and so the problem is when you stick a view in there and you're using auto layout, because that plane stretches from infinity to infinity. What we just said, trailing, leading, bottom, top to the super view. Well, the super view is the scroll view, and it's an infinity, right? And so in order to do what we want to do here, what we're going to do is we're going to take a little, we're going to use the little helper here, and we're going to say add missing constraints. Oh, right there, add missing constraints. And so it actually went, and it did something that is really smart. It says we're also going to align our center X, and we're going to align our center Y to our super view.
So that it's in the center.
So that it's in the center.
So even though it's infinitely tall, we're seeing the middle.
Yeah. And so, and then we're going to go.
Mine didn't do the Y. Same with mine.
Did you click on the missing constraint thing?
Yeah.
Line center Y to super view. Line center X to super view.
That's because you have a height constraint for some reason. Probably because it's not filling up your whole thing. Go delete your height constraint. So I'll try it again. Make sure that it's
In the scroll view or the.
right here.
What do you think of this thing, Scott?
Alright.
This
Do I delete it just by selecting and delete?
Yeah, selecting and delete.
Spend enough time
Okay.
getting to know it. Probably be cool. Yeah. Is there something comparable in Android?
Yeah, I mean, you have visual layout, drag it.
But I mean, do they have all these constraints and crap?
Should I just
It's not
delete
like
the scroll view?
this. You have layout managers.
Same thing. The reason they've done it
It's
this
got to be one of the
way is
ones
so
that I
they
didn't
can
expand all the way.
file how are they supposed to work?
Well, probably. Just tell it to align. If you didn't get your thing, you can just tell it. If you end up getting the wrong constraint, you can say vertically centering container right there.
There.
And then, so if you end up getting a height constraint instead of the align center X and center Y, you can just go here and say, and check on that one, vertically in container. You'll have to have your view selected. And then just click on that, say vertically in container, and hit add constraint, and then it will fix it for you.
Okay.
All right, so is everybody caught up?
Mm-hmm.
Okay, so now go click on your Hex Game View controller, and then go up to View and say Assistant Editor, Show Assistant Editor. It's going to slap this thing on the bottom here, and we're going to start dragging some things down here. So you're going to click on your scroll view, and then hold the Control key down and drag downward, and we're going to insert what's called an outlet. You probably remember this from last time.
That's right.
We're just going to call it scroll view. Hit connect.
Wait, so control, and then from the scroll view, I drag.
You drag down into your assistant editor below the interface part, and it's going to stick a property in there, an outlet, for that scroll view. So what this has done is now at runtime, our view controller is now connected to the scroll view, and we have a reference to it, and we can do things with
What
it.
did you name it?
I just called it scroll view. Scroll view camel case.
Now,
You added that code at the bottom.
This is boilerplate code
Okay.
so far.
Okay, so you have
This is the first stuff we're really adding.
So how'd you know? this was
And then click on the view and do the same thing. Now we're going to call it, control drag. And this one we're going to call game view camel case. Or whatever you want, but that's what I'm going to name it. So
Where is the code? I mean, where is this code?
we'll see it in just, I mean, what we're looking at in this assistant editor is the actual code itself.
So I
Right?
need to add 2 outlets, right?
Yeah. So usually with iOS projects, it's helpful to have more than one tab. So now that we've done this, just hit Command S so you save it, and then hit Command T, which will create a new tab in our interface here. So now we've got 2 copies of the storyboard. We don't really need 2 copies. So if you hit Command Control W, it will close the file in that current tab,
Ah,
and we can get rid of this.
I don't know. I think I did something wrong.
so do I ain't got nothing to show.
I don't know why it just did that. That's weird.
All right.
What should we have open?
Hold
I'm
on.
all messed
Hold on.
up now.
Okay. So did you hit Command T?
Well, I did, but my other tabs messed up because I tried to close something.
Okay. So Command Control W. If you go up here to the file, you can see these same things. Command Control W is this one right here. It closes the file in the current tab without closing the tab. Close tab is Command W, which we didn't want to do. We want to keep the tab open, just close the file. So you should have main storyboard on the right, and then go over onto the storyboard on the left and just click on Hex Game View Controller. And now we have a source file in the one tab, and we have our storyboard in the other, and you can switch back and forth.
How did you add that outlet?
So the outlet was by control dragging in the storyboard.
So I add an outlet here and control drag into the. Oh, I get you. Screen.
Steam view controller.
Yeah. So
Hex King View Controller.m.
you need that your assistant editor should be on the bottom.
He's got this dot. Yeah.
How do I move it to the bottom? Move away.
So you can put these outlets in the .h or the .m.
Mine's in the .h for some reason.
Okay, well, that's fine. I mean, they're going to end up the same place. If you put them in the .m, it just means that if those won't be exposed to the outside world.
I got it.
what if I put them in the main storyboard?
So
I don't know what's where here. So
you
I'm on
want
the main
to
storyboard.
close
we're
that.
in tab.
You want to close that one. You want to do
Yeah.
Control Command W on that.
So-
click in there first.
Yeah, you guys all did assistant editors.
Yeah. How did
you guys
you get it?
You say View Assistant Editor.
On the bottom.
Assistant editors on the bottom. And then when you say assistant editor,
Show it.
oh, that, sorry, show it.
How did you get it to shoot?
Okay.
So you go to View Assistant Editor.
It seems like you
show
wanted
on
that
bottom,
opened.
and
it's
then
its own
and
file.
then just
So
say
I
show
just have
assistant editor.
That here
There you go.
and whatever .m here.
So now.
So on one tab, so keep this main storyboard open, that tab, and then over here.
Open that down there. Let's go.
Now just go click on
Did you check out existing project? Or just
and then close
Start
your
from scratch.
this guy?
So now we have code. Now yours looks like
But,
mine.
but you don't need the system editor down there too. Get rid of that, right?
We're going to use it again later, so
Okay.
keep it open.
And then how do you add drag and drop the outlet?
So open up your view and open up so you're gonna open expand that. So you're gonna click on scroll view and then control click and drag down to here. Control drag. Control.
Drag this all
Sorry.
in.
So
Why
let go of
That's
it
why we have the same
So
thing
control,
showing in-
and now drag it.
We've got the code
Here
showing
or
here all by
Right down
itself, and here down
Boom.
below.
Drop it and then call
Okay.
it scroll view.
Okay.
With
Yeah,
a small
whatever.
s.
We'll see in a minute, guys.
Just going.
Camel cases.
I'm going
No
with
camel
it.
case on.
Well, so camel cases, you start off with a small letter,
Oh,
and then
okay.
every word after that is then
Camel.
capitalized.
Okay,
like
so we have
camel.
scroll view. Next.
And
How do
then
we do it for
do the same thing from view and call it game view. All right. Anybody else need help?
no.
Everybody else good? Joseph, you good? Josh, you good?
I need something
Yeah, I'm
bad.
catching up. I had something wrong there. So go ahead and install it again.
Okay.
It's just I wish I had a monitor right now.
All right. So now that we're in here, we're going to do one more thing. We're going to create a custom view. So we're going to go click on Hex Game in the left-hand side, the group that we created, and we're going to say New File. It's going to drop down this thing. We want iOS source code, Cocoa Touch class. Okay.
All right, new file.
So this is like creating a custom view, like this can draw the hexes and stuff.
Yeah. So we're going to create a custom view here called, it's going to be a subclass of UI view, and we're going to call it Hex Game View. Oddly enough.
Sweet.
Hit next. It's going to ask you where you want to save it. Here you could actually change the group if you wanted to, but we don't want to because we already right-clicked on the right group.
Mine says UI table view, and yours
Change it to UI view. Type UI view down there. Just type it.
Where do I want to save it?
You want to save it into the Hex folder there.
Create.
Where in the hex folder does it go?
Oh, you know what? No, this is my bad. We should have put these groups under here.
game views.
My bad. Yep. Those should be under Hex itself. There we go.
Instead of hex.
Yeah, and then the files will end up in the right place. Sorry. So drag your groups so now it looks like this. You should have Hex at the top, and then another folder that says Hex. Under that, you should have Engine, Hex Game, and then these other files. Okay.
Wait. No. I don't have that. I have the top level hex, the blue, and okay, I do have.
Yeah. So drag those other ones so that they're under the other Hex.
Got it.
Then it should put the files in the right place by default.
Gotcha.
Okay. So now we've got this Hex Game View. So click back over to our main storyboard. And if you need to, reopen up things so we drill down to the view that the game view that we have inside the scroll view. Then we're going to click on this thing that looks like a
Reopen. Mine closed. Just reopen.
Postcard.
Go to main.storyboard and double click.
Where's the game view?
Go to main.storyboard and double click it. It's not. It's mine. For some reason, it's not.
Yeah. So you need to have another. Oh, you're right. There you go. That's right. Yeah, that's right.
Okay.
Then go click on main.storyboard, and then inside there, just go select game view. There you go. Everybody got game view selected? Okay, then we're going to click on this over in the right-hand pane at the top. We're going to click on the little thing that looks like a postcard, the identity inspector. So you should see where it says custom class. Everybody see that? Okay. And you're going to in there. We're going to start typing game view. Oh, sorry, Hex Game View. Sorry, Hex Game View. I'll fill the rest in for it. Just hit enter. We've now set the custom class. This view, game view that we have here, is now an instance of our custom class, right? So if we were doing like designable stuff,
Oh, I see.
we could then, it would then render whatever we told it to render inside of the storyboard stuff. So
we right, and then it would have had to have been an instance of a view, or this would have broken.
right.
Or would
Well,
have showed it to us.
No, it doesn't matter. Once you set it to a custom class, it just under the covers it says, okay, this thing is now this. So
We got it.
yeah. All right. So click back over to our tab here, and we're going to make that Hex Game View look like this. Okay. So you're going to type into you'll notice, this is mine over here. You'll notice that we don't actually have this thing yet. So we're going to create what's called an interface extension. So you're going to hit the @ sign and start typing interface.
You
And it's
got
gonna-
H or the dot M, dot M.
You're in the .m. Hexgameview.m. Hit the @ sign and start typing interface. And there's three options: Objective-C class declaration, Objective-C category, and Objective-C class extension. We want the class extension, which is also called Hex Game View. And then we're going to open the curly braces because we're going to declare a member variable. UI view. I'm going to call it square view. Square view. Okay, so far so good. It looks the exact same. There we go. So down here, then we're going to go create, we're going to override a method. Oops. Yeah. So hit the dash sign, a space, an open paren, the void. So this says the dash sign is this is a member method, right? A member message. And then the thing in the parentheses is the return type. And then the name of the method is called awake from nib. So a nib file, under the covers, everything becomes a nib. And a nib is actually, I think, a technically really cool thing. What they do is whatever you've designed in this storyboard, they take everything that that's what is living inside there is an actual instance of your class. And they take that sucker and they serialize it down to disk. And then when you instantiate it, it is reinstantiated directly off of disk. So it's basically like you take a class at that moment in time and you freeze it and you store it off, and then when you're ready to use it in your runtime, it comes back exactly the way it was inside of your storyboard. So, and that is the thing that does all that stuff under the covers is called a nib. And so whether you're using an XIB, which is an XML interface builder file, or a storyboard, everything eventually gets compiled down to a nib, which is a binary format. So
You could do everything with an XIB, which is non-visual. It's an XML document.
no, XIB is still visual, but an XIB is a single thing. It's like the direct correlation of a nib, but it uses XML to represent the structure on disk, so that it's easily savable for, like, source control and stuff like that. First thing we're going to do is every class has, sorry, whoops, I hit the wrong thing. So hit the bracket, start typing super, and it should autocomplete to our super call to awake from nib. And inside of this is where we're going to do a little bit of configuration. So we're going to create a new view. So you say UI view. Oh, sorry, we already have the member variable. So we're going to say square view equals. I have two brackets because we're going to allocate an instance, and then we're going to initialize the instance. We want the init with frame. Okay.
I love this syntax.
CGRect make. So what we're doing is we're making a frame, a rectangle. It has 4 parts: an X coordinate, a Y coordinate, a width, and a height. And rectangles are used all over in Objective-C. So our X, we're going to start off at 50.
How do you get it to auto-complete the square view?
I just start typing and it does it for me.
Yeah, that's what it is.
If it doesn't do it automatically, then hit the escape key and it should bring up your code completion. So 50 for the X, 50 for the Y. We're going to do 100 on the width, 100 on the height. Okay. And everybody tell me when you got to that point. I'm having you type this out because it's not going to be that much. When we end up, there's not going to be that much code here. So I figured it'd be a good learning experience to learn a few things that you can do. So next thing we're gonna do is we're gonna work with the views layer.
The first thing we're doing is we're just drawing a rectangle on the screen.
Yep. That's what we're gonna do. So a layer. So when Apple came out with Core Animation, they went to this concept where every view under the covers is really a core animation layer. And that's why everything in iOS is animatable. From changing colors to changing sizes to changing alpha to, I mean, almost anything you can do to a view is animatable, because what it's really doing is the layer is what draws your view. Okay? And as such, there are actually properties and things you can do on the layer that you can't, that aren't exposed on the view for some reason.
It sounds like Shockwave.
So
That's exactly what Flash is.
one of those things is borders. So we're going to put a border. Is that what I'm doing? Yeah. So we're going to do a blue border. The border, we're going to choose the border color thing. Now, since we've dropped down a layer conceptually somewhat, we can't use UI kit functions all the way. So we're going to say UI color, blue color. And then we're going to use the dot operator to grab the CG color object, which stands for Core Graphics Color Object. Because Core Animation uses Core Graphics, UI Kit uses the UI stuff. So UI color, UI view, CA layer, CG color, right? Okay. And then we're going to, and then we're,
Stuff isn't that complicated. You get to know the layers.
square view dot layer, and then we're going to set a border width, because we've set a border color, but right now the width of the border is going to be 0, so you won't see anything. So we're going to say the border width is 2.0. And it seems like there was one other thing. Oh yeah, we got to add the subview. Oh, I did 1.0. So let's do 1.0. And then we're going to add, so then we say self add subview square view. Okay, so add subview just says, so we are in a view object right now. We say, hey, we're going to add the square view as a subview of ourselves. We've already set the frame. So we said within your coordinate system, you're going to place the subview at 50 and 50, and it's going to be 100 pixels wide and 100 pixels tall. Okay.
You're going to slight tangent. Tell me where all the brackets mean. Why brackets everywhere?
Okay, so a bracket, a bracket can be used for 3 things in Objective-C as opposed to 1 in regular C. In regular C, a bracket is only used for one thing, and that is as the index operator, right, on an array or an object or something. In Objective-C is a superset of C, which means anything you can do in C, you can do in Objective-C, plus it adds a few things on top of it. So it's a superset, right? And one of those things it adds is the ability to pass messages among objects. And so the bracket, the bracket is basically the start of a message passing operation. If you see a bracket that's not immediately connected to a variable name or something like that, then you are doing a message passing operation. And so, and in order to nest them, just like with nested functions calls, you end up with a whole bunch of parentheses. Just in your mind, just say parenthesis equals bracket, and then all of a sudden you have it, right?
You're making a bunch of function calls.
So you're making a function call. So this right here is saying we're calling the alloc method, the allocation method on the UI view object. And then the second thing is we're saying, and now we're going to call on that, and that allocation gives us back a newly created but uninstantiated instance of a UI view. And so then we have to call its initialization method or its constructor init with frame. And there's actually 3 different ones for almost everything has just a plain old init method. And then they usually have another 1 or 2 on top of that that do different things. Init with coder is used when it's being woken up from a nib. And init with frame is the programmatic way to create a view. You create a view, and at the same time, you tell it where its frame is. So,
Put in the colon there.
and then and in Objective-C, method names, the parts of a method name are part of the method itself, and so it basically gives you names, and the colon is part of that name. The colon says this is not just the name of the message. This is actually a parameter as well. So you're saying init with frame, here's my parameter. If we had a second method, we would have another name followed by another colon. If we had a third argument, we'd have another name followed by another colon, right? And so it looks a little weird at first, but once you get used to it, it makes it really readable because it breaks up this method call, and you know exactly where in this big method the names are supposed, like the parameters actually go.
Like
Huh?
I understand it, I can do it, but I've never.
Oh, well, you haven't ever coded in it for very long either.
Swift won't be doing it for much longer.
So, so that's why the brackets. So,
Okay.
and then here what we're using is we're using the dot operator, which is a Objective-C 2.0 syntactic sugar. You could also write this as square view layer. And sometimes you forget that you need multiple of these things. Set border color, blah, 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 right? This and this are the exact same. They don't look the exact same, but they are the exact same thing. So. Anyway, so that we've done that, let's see what else. Okay, so layout subviews, what we're going to do in there. So auto layout, I really hated at first because there were times when I just wanted to do something. I wanted to put a view where I wanted to put it, and I couldn't figure out how to do it. Well, it's because I just needed to read the documentation. This is where you go. Layout subviews, calling super layout subviews just took care of any auto layout stuff that needs to go on by the system.
What do you mean by that?
So let's say our Hex game view has just been resized from being the entire screen. You know, we're on an iPad mini and somebody decides to multitask, and so it's shrunk from the entire screen to half the screen.
We'll do all the recomputation.
This is eventually layout subviews is going to be called because this thing has been changed. It needs to be relayed out, and then it's going to take those auto layout constraints from the linear equation, solve it, and then it knows where everything goes.
Well, why are we needing to override? Because we're going to do something special.
Well, because we just create our own little frame here, our own little view inside of ourselves that we did not give any sort of auto layout constraints to.
So we have to do it ourselves.
And so what we're going to do is, if that happens, we're going to say, hey, once we've been laid out, all we want to do is we want to say, take our little square here and stick it in the center of the screen. So the center is a property of type CG point. So we're going to say square view.center. We're going to make it a new point, and that's going to be in our receiver's coordinate system. It's going to be in the middle of the screen XYs, in the middle of the screen YYs.
By putting the .o on the 2, it makes it a float.
Yeah, and you don't necessarily need to do that because self.bounds.size.width, that thing is a CG float under the covers. It's already a floating point. Well, it's a double, but I just like to do it to be explicit, to know that I'm doing floating point math and not integer math. So, but because of the type coercion stuff, I could have left it off and we would have been fine. But it's long established habit. All right, so the only other thing I think we need to do in here, so there's a couple of pieces of code that we need to copy into our Hex game view controller. One of those is to set up the zooming properties of our scroll view. So we're going to say that the smallest you can get is just the actual size of so minimum zoom scale. That says scroll view. When somebody pinches inside of you, don't let them pinch to zoom out any more than the actual size of the thing. So we're saying 1.0. If we wanted them to be able to make it even smaller, we could say 0.5 or 0.25 or whatever, right? And they could make it as half its normal size or a quarter of its normal size. And then we're going to say, and we don't want them to go any larger than 5 times the normal size. So we set the minimum zoom scale and the maximum zoom scale with those two things. Everybody chime in when you're done with that.
Gotcha. Good.
I've got red marks on here.
Like to go.
Oh, sorry. You're going to want. I forgot. These two things. Synthesize scroll view. And you don't have to synthesize if you want. So one thing they introduced is auto property synthesizing. And with that, what they do is they actually create a member variable because they want, everybody was naming their variables like this. They're like, well, we want to do auto property synthesizing. And what can we do? Well, if we start creating member variables with names without underscores, it's going to clash with everybody's variable names that they've already been creating. And so if you do auto property synthesization, it's going to be underscore whatever. If you call synthesize explicitly, then it does it without underscore.
Walk up higher. Where did scroll view and game view come from?
They come from right here. So those we connected in our storyboard.
Correct. And so that gave us access to those views via these variables.
Yep.
And so the synthesizing this allows me to access it with a prettier name.
Just as a class or as a member variable, as an instance variable, rather than with a property. Because we could have also said self dot scroll view dot.
And so that this is just simplifying it, so I don't have to say self dot to access the property.
Exactly.
All
Yep.
right. I never understood that.
Yep. So, and then the last thing. So Scott, I really am not saying this to slam Android. Okay, I just want to preface that. But you know, but Scott said last time that one of the things that took him so long was finding that code that would allow the scroll view to do that stuff, to be able to pan around, right? So this is all you have to do in order to be able to pan something in a scroll view on iOS. So
we need to override a method?
Yeah, we're going to override a method. Well, we're actually going to be doing delegates. Oh, sorry. Whoops. Let me go back to main.storyboard for a second. And click on your scroll view in that pane right here. Is everybody there?
Yep.
Okay, then hold down the control key. You're going to drag from scroll view up to Hex game view controller. Let go and select the delegate outlet. Now we could have done that another way. Over here in Hex game view controller, we could have just said scroll view dot delegate equals self. Right? We could have done that. But
We did do that. We did it visually. Where did it?
Yeah, where'd it go?
Yeah, there we
Where'd it
go.
go? I don't see that.
there is no code. It made the connection.
So we need that delegate for that reason.
So the delegate is going to come into play here in a second. So then we're going to come up here, put in an angle bracket, and start typing UI scroll, and then go to the second one, UI scroll view delegate. So for those of us who have done Java, this is a protocol, aka an interface. So if you're coming from Java land, just substitute interface for protocol, and that's how you tell the compiler that I am implementing this interface or this
When
protocol.
you mean what? Because I see at interface hex game controller open close paren, and then that thing is inheriting.
This Hex game view controller is now implementing the interface
Okay.
UI scroll view
ends 3
delegate.
lines down, which means we need to put the implementation there.
So and then, so this pragma mark, so a protocol is like an interface, but you can actually have optional methods in a protocol, unlike an interface.
Okay.
And most protocols, the methods in most protocols are optional because you don't have to implement them. The system just assumes default behavior if you don't implement the required methods.
So I want to do a pragma mark so I can delineate my protocol methods.
Yeah.
Is that right?
You want to be able, and that comes in handy right here, right? So when you click on this little thing, this little class area, up here you have like your breadcrumb trail. If you click on the farthest right, it shows you your interface, your implementation, and every time you put a pragma mark, it puts this text right there, and if you put a dash in there, it puts in that line. So it gives you some visual separation when you're trying to find various things. Now, where do I put, where's that action method? Oh, it's down here, right, with my actions. So, and then all this is saying is, this is a delegate method. The scroll view is going to say, hey, when they're pinching and zooming, is there a certain view that you want me to act like that's what they're wanting to pinch and zoom in on? And we're saying, yes, there is. If you're our regular scroll view here, then we want you to act like the game view is what they're actually pinching and zooming. And so, as you'll see when we put this on our device in about 10 seconds, as we pinch and zoom, our little square that we put in the screen is going to get bigger and smaller and bigger and smaller. And it'll pan around and et cetera, et cetera. So, we'll grab your cable, plug your device in. See, I gave the Android emulator a hard time last week, but for some reason Apple hasn't done I mean, our trackpads are perfectly capable of doing these pinch gestures, but they don't map it into the simulator. I don't know why.
Really?
I know it's dumb, but well, it is what it is.
I think I've got the cable.
So,
if you want to run this on the simulator, do I hit the play button?
yep, if you want to run the simulator, just hit the play button. Otherwise, you're going to want to do what I just did. Once you got your device plugged in, come up here to the little area and choose your device name. So, and then I'm going to hit, you'll want to make sure your device is unlocked. Launch.
How do you make sure of that? Oh,
Just,
turn it on.
yeah, just get off the lock screen so you're on the home screen. So I'm going to hit the button. It's building.
Sorry, I missed it. Which button runs it on your device?
The little little play button, but you have to, if you got your device, you want to select it up here in the top.
I've got
That
errors.
stuff's similar. And if everything in right, it should look like this. If I pinch on my screen, my square gets bigger. I can scroll it around, la la la. If I pinch back down, it comes back to the center. And that's
Phase one.
phase one. That's the Where's Waldo implementation. I just figured having him copy the image would be, you know,
Could not find developer disk image.
I have no idea.
Processing symbol files.
Yeah, yours, yeah, so it's going to take a second until it's done.
Dang it, man.
But you should just be able, now you should be able to hit play. It should work. No, still processing the symbol files. Okay, well, once it's done processing the symbol files, then you'll be able to run it.
What the heck? Could not find developer disk image. So PS grants iPhone. Away. Okay.
Did you not let it install the stuff? Go to Xcode.
Hex has 2 issues, that's why.
Services.
All right, let's do it. I'll figure out how to just go back to.
Just go run this. What were your errors, Joseph? So those are errors. Those are just warnings. What it's saying is you didn't correct there's a mismatch right now in your storyboard between the actual frame for your scroll view, the way it's designed, and the way it's going to look at runtime. And so this is just telling you, hey, if you think it's going to look the way that it looks in the storyboard, it's not really going to look that way because the auto layout constraints are going to change the size of the frame once it's actually running.
I think my issue was
Which in our case is not really that big a deal because all we're doing is saying, hey, views take up these screens. But if you're looking at your view and you think your button's going to be 40 points high, but you haven't set an auto layout constraint that's really going to make it 20 points high, then it becomes a bigger deal, right? So that's why it's just a warning.
my issues were I didn't pull it to the right side.
My computer can barely handle it.
Oh, did you do a 6 Plus?
No, I did 5S.
Oh, the 5. Oh, that's the 5S? You might need the, I think you can tell it to show it at, oh, because yours is it a retina? Is it? Okay, that's the problem.
So Grant, on my views, I somehow didn't pull it to the right size, and that's why I'm getting these 2 frame errors.
Yeah, so those aren't errors, like I told Joseph.
They're just warnings.
They're just warnings. You can
Okay.
build without them. So, and that's the end of version 1. So in the next one, we're going to replace our square with a hex tile. And then in version 3, we're going to replace that hex tile with
It says my build failed.
the grid.
No code signing.
I just think about doing this app in the landscape instead of up and down.
It said what?
No code signing
Do you think it'd
identities
be
found.
better if it was
No valid signing identities.
Yeah, I had 5 pair or
Oh.
not.
You don't have a certificate to
But because I think I
You
played this.
probably don't have.
So I played games this way.
So you probably need to go in here to
So
preferences and accounts. You need to add.
After he does this, I do mine next week over at Flush. Okay.
So whatever you use, I think you use jtebetter at shout.tv. Can't remember, but whatever you used for your test
We're
flight
gonna get into
thing that when you accepted the invitation, that's what you want to log in with as.
The week after that. Okay.
All right.
And that's where you actually have a play.
Grant,
Yeah,
should I be able to pan and zoom
on your device?
on the simulator?
No.
Okay.
Well, you could if you could pinch in and out, right?
Yeah, like I can't teach
You can't pitch in and out, so you can't pan and zoom. So yeah, I mean that it's kind of like it was last week with the Android one, right? I mean
That's fine.
it looks you can do more stuff on the device. So
How come it's taking so much longer in mine than yours to process it just because it's the first time device?
that's the first time you've ever plugged that phone into Xcode, and because of that, it's going to take a while. That it's processing all the symbol files, so it knows how to debug and everything. So
Makes sense.
all right, so a couple of you haven't been able to run it yet. Do we want to wait until
Who hasn't run yet?
Joseph and Matt?
Mine failed, but
Are you following along, or you're just looking over there?
Well,
You're just listening.
I'm paying attention, but I'm
Okay.
not following along.
You're not actually programming.
Process launch failed for security. I need to tell.
So then go tap on it.
Okay. I'm trusted developer.
turn nil.
You can allow these out from settings. You're a trusted developer.
I know.
How did they know that you're not trustworthy?
Check the internet.
Heck, I don't even know what to do.
It said Joseph that is untrustworthy.
You can allow these apps from settings. General.
Oh, look.
Yeah, do a quick Google search. I don't know. I'm not sure.
Process launch security.
I haven't upgraded my Xcode version,
Okay.
but the iOS stuff hasn't been upgraded, so there's a mismatch. I have to downgrade my build target by going to general settings, which I don't know how to find yet. I'm changing my deployment target from 9.1 to 9.0.
Okay, I see.
You know where that is? General settings.
So go click on Hex. I gotta get rid of
Settings, general profiles. Settings, general profiles.
Release.
Oh, I put down there. Scroll.
General device management.
What do you? What do you?
For this, I've been using 9.0. For Flash, we use 8.0. So. You know what happened?
I was using UI scroll view, but I had a lowercase.
Oh,
I just fixed a couple of those, and then the only one I don't know, I'm missing an end. So fix that.
Now, when you scroll in, should it pop back out? Oh wait, yeah, because we said
Let's fix it.
minimum of 1.
Right, and this is the last one. I'm confused on this one because it says Hex Game View Controller.
All right. Yay, it works.
All the other ones, I understood the errors. I don't understand the error.
It's the declaration. Still lowercase. Oops.
That was all my errors. Was because I didn't capitalize on making.
There we go.
Lowercase. Cool.
It should. And then because you did that, then you need to change get rid of those underscores.
Xcode is only a mere 4.41 gig.
Now I'm gonna camel case it there because I didn't camel case it other
Are you on the
places.
most recent
Did you
version,
update the whole?
Oops.
Well, I mean, as of last week, I doubt
Version.
So now it is camel cased.
I'm on 7.1.1.
7.2.
But I'm just missing out. And
Let's do that too.
Why is this thing showing up down there? That's Can we run this in Eclipse?
Huh?
Can we bypass Xcode and use Eclipse?
No.
No one's done like a bridge or anything.
I mean, you might be able to, but I mean, you're gonna have to have Xcode installed to do the compilation and stuff.
I was just reading.
Yeah.
Well, unlike Visual Studio, Xcode is free, so I don't think there's really a huge reason to not use Xcode.
All right. So let's go close up shop on version 1. And we're going to open up version 2. All right. So bring this onto this screen over here. So one of the things we're going to do is we're going to go create our hex tile class. So let's go do that first of all.
Underneath. Is that hex group?
Yep. So under hex game, you're going to right click, say new file, or you can go to up to the menu and say file new, Cocoa Touch class. It's going to be a subclass of UI view, and we're going to call it Hex Tile.
Excellent.
This is a new file.
Yep, new file called Hex Tile.
Cocoa Touch class.
Yep. It's going to be a subclass of UI view. Call it Hex Tile.
My H.
Yeah, so it highlights both of them. You'll want to just click on one or the other. So our .h file, we're going to introduce an enum. It's going to give us a type of hex tile we're going to use. So an NS enum is that's a macro. And it basically sets up this enum is of type int. Its name is going to be hex tile type. Give it a type def so we can actually refer to it places in the code without using enum in front of it. And then we give it the names. We're going to have hex tile type, flat side up, and point up.
It's an enumerated value.
It's an enumerated value, similar to Java or other languages.
If you're not familiar with the try down.
They're only it's a value that can only have certain
Discrete values.
certain discrete values are the only valid values for it. So it's not you can't just put any int into it and have it be a valid thing. It has to be one of the enumerated types.
You could say string as well, so not just have int, right?
Not in Objective-C or C's in general. That's something that
Then why force it to say int on that first argument?
because you can actually declare it to be of other types. You can have like a char enumerated value or
Unsigned.
unsigned long. It's just more explicit on what the actual storage parameter is for this thing. It's going to be an int. So, and then the other thing we need is we're going to create a helper class method.
What does the plus mean?
So if it's a plus instead of a minus, that means it's a class method as opposed to a member method. So in Java parlance, it's a static method versus an instance method.
Pluses are static.
Pluses are static,
What's the name?
minuses are instance.
Tile of type.
Yeah, so the name of this method is tile of type with frame.
And then so you do a colon. Eyes are starting to get blurry.
So tile of type colon hex tile type.
Why the plus in front?
So the plus makes it a static method rather than an instance method.
Tile of type.
So in order to call it, you would say something like hex tile blah 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 instead of using an actual instance.
Parameters there, they're the same.
Yes.
Yeah. So you have two parameters. One of the tile of type. You have a type parameter, and then with frame is the rest of the name, and you have a frame parameter after that. And normally these correspond closely together, so that you can infer from the method name what arguments are going to be passed to it. You'll notice that I've done that sometimes when we've done our Java methods, right? Give it a long descriptive name so you know what needs to be passed to it. Objective-C kind of formalizes that. And then we're going to have one other thing on this object. It's a type. Property, non-atomic. So these things that when you declare a property, the stuff in the parentheses are like modifiers on the property. So you can have atomic properties, so they're thread safe. You can simply thread without doing any locking. Most properties are declared non-atomic because that's overkill for most objects. There's also strong and weak. Strong reference means that it partially owns that variable, and that variable will never be deallocated until the strong reference contained in this class is released. Weak just means I have a reference to it. When the system deallocates it, it will go find my weak reference and set it to null, so that we don't ever access free memory. Yeah.
Okay.
So this, if you don't give it a modifier like that, then the default modifier is assign. So it's just a straight assigning, and since it's a primitive type, that's what we want. So we could have been explicit here and said non-atomic assign if we wanted to. All right, everybody got that?
I'm getting errors on the tile type.
Just type right hex tile type.
Got all your colons in?
Can't have a space between width and frame. All right, so, oops, the wrong key. There we go. So I just switched over to our implementation. This is what our implementation is going to look like this. To speed this up, and since Scott has already gone over the math, I'm just going to copy this into an email and have you guys type it. So we're going to do this right here.
Yeah, by the way, this is what I sent around after my last class when they figured out the math properly. So when I do my class again next week, make sure you're kind of
Whoops, going the wrong way.
version. I'll send it around.
So send it to stand up.
Looks better that way now.
All right, so you're gonna grab this stuff, and we're gonna.
Geometry, and it's at 30 degrees. Just add 30 degrees up here. Okay, now where do we put this? This is hextile dot.
Hextile.m. What I just emailed you, you're going to cut and paste into hextile.m. Except for I forgot this one thing, so you're going to have to type this one in. Sorry. We're going to create a little macro, C macro, that just simplifies the process of converting between degrees and radians.
I love pound defines.
So that's the macro you're going to have to type in at the top. Basically, for those who are not up on their geometry, most functions inside of a computer that operate on most geometric functions are expecting that you're going to express your angles in radians, and most of the time when you're learning in math in school you did degrees, and so this is just an easy way to convert between them. To find the radian value of a degree, you just say degrees times pi divided by 180. So that's all that is. So while you're typing, let me just talk about the approach a little bit. So Scott's, I did modify Scott's just a little bit to be more in line with what you would do with Objective-C, and also to illustrate that there's other ways other than doing the offset by 30 degrees. So what we do here is we actually always set it up square side or flat side up. We just do the math that way. So we have 0, 60, 120, 180, 240, and 300 as our angles. And what we're doing here is we're creating a Bezier path. So a Bezier path is a set of points. A path can be either closed or open. In this case, since we're creating a hexagon, we're creating a closed path, and that's going to have some advantages that we'll see later on.
Real quick, I'm getting an error that I can't find degrees in the pound define.
It has to, so you pound degrees to radians, open paren, degrees, close paren, and then you're going to use that same value later on in the other part of your pound define.
How does it know M underscore pi? Where
M underscore pi is just coming from the math library. It's like an auto include because we're using UIKit. and the math libraries use
M
all of it.
underscore means math.
Yeah, math underscore pi.
Okay.
So, yeah, if we clicked on it, it would take us to where it's defined.
So freaking cryptic.
Is in math.h.
That doesn't have any precision.
I know it's not pi to 1,000 places like
It's embarrassing.
the what's his nugget, the white nerdy guy.
Oh, yeah.
Weird. Yeah.
Yeah, weird. So anyway, so we're creating a bit Bezier path, and then we're going to do. We're taking just because the math doesn't actually depend per se on actual coordinates. That's just for positioning whatever you do. The math is the same for every hex tile that we create. So if we wanted to, we could really just cache these based on their size, or something. I'm just creating them new just because
Simpler to illustrate.
simpler to illustrate that way. So we create a new Bezier path. We find the center of our our size gives us a box, basically width and height. The center of that is our point. We have our radius, which is we're going to just be, since we're doing flat top on top, then our radius is the width of that box, because the corners of the hexagon, their widest point is at these two vertices, and those are going to be touching the edges of our bounding box. Okay, and so our radius is that divided by 2, right? Because if you go from those two vertices into the center, that's our center point. And then we're going to just be doing some basic path math. This is very similar to what Scott was doing with the draw calls. We're just saying, hey, we're going to move the inside of our path, we're going to move to this point, which is the first vertice at 0 degrees. And then we're going to add a line from there to the one at 60. We're going to add a line from the one at 60 to the one at 120, from 120 to 180, from 180 to 240, from 240 to 300. And then the last thing we do is we say we're going to close our path. And by calling that method right there, it says, you're currently at 300. We want you to draw a line back to your starting point, which is 0. And so now we have a closed path hexagon, square, flat side up. Then, if you do any sort of graphic stuff or animation or various things, you can't hardly move, like read a piece of documentation where it doesn't talk about core graphics, affine transforms. Okay, and so what we're going to do is, if we decide that we want pointy side up, all we're going to do is we're going to take that path that we've just made, and we're going to rotate it around its center 30 degrees. Okay, so in order to do that, we grab the bounds of our path before we do anything else. That's an important part. You want to grab your bounds right up front and create a center point from that. Then you're going to start off with that identity transform. This is like linear algebra for those people who took that in school. Linear algebra, you're going to start off with your identity matrix, and then you're going to add a translation matrix on there. So we're going to transform. We're going to say our origin is no longer 0, 0. Our origin is the center of our shape. And then we're going to say, okay, our origin is now the center of our shape. We want to rotate that entire shape around the center, around its origin, 30 degrees. So our point, if you look at the diagram over here, that point at 0 degrees is now going to be at 30 degrees, etc. Right? And then what we're going to do is, since we just translate everything, we need to say, okay, now move the origin back to 0, 0. So we translate it to the center of the shape, and then we're going to undo that by doing the negative, by doing the inverse. And then once we have that transform set up, all we have to do is tell the path.
Everything made sense to me except
Apply it.
Why reset the origin back? He doesn't just automatically do that much on the transform. Really?
No. Because what it really did is it shifted all the coordinates, and then it rotates them, and then it shifts them back.
Otherwise, when you try to get taps or whatever, they'll be off, right?
Yeah.
I guess. All right.
So, and then we just take that
That's
path.
really similar to OpenGL.
Yeah.
You're pushing and popping matrices off of the stack, and then you're applying transforms. Which is probably what it's really doing under the hood, right?
Yeah, it's just doing a linear algebra equation with matrices and stuff.
Well, I wouldn't be surprised if this happened with GPU, right?
Yeah.
I'll bet.
Yeah.
So it applies the path. We we tell the path to apply that transform, and then what we get back if we're pointy side up is now we rotate our thing 30 degrees.
So
Now
one
we
of
could
two-
have done what Scott did, and it would have been just as simple to say, hey, offset all these by this offset. But
now if
I want
we
you
can
to-
make all of them spin. We can make each cell spin independently.
we
as an
could
animation.
make them spin an animation. That would be cool. So
Headache.
so
Whatever you tap it.
so the implementation of tile of type, all we're doing is we're just saying, hey, alloc this thing and with this frame and this type, and then send it back. So then we look at our init method. Okay,
That's
we're gonna
factory static.
that's the factory stack method. It's just a helper, right? So you don't have to say alloc and init and blah blah blah. You just say, hey, here's the type of tile and here's the frame, and give me one back. It does it. So we save our type. We create our path using the size of our frame. Now, there's a potential for some fuzziness here. If you've caught it, good. If not, we'll talk about it later and we'll correct it. But we're going to say give it our frame size. We say, okay, if our tile is going to be a point up tile, then we're going to rotate our path by 30 degrees. We're going to create a shape layer here. So a shape layer, we saw that every view has a layer. Well, every view or every layer can also have a mask. And what a mask does is it says anything that isn't described by this layer, usually it uses opaque pixels, but with a shape layer it does something slightly different. Anything that's not described by this layer is not going to be visible. So we've created the shape of a hexagon, and we're going to say the background color of our view is light gray. But since we've created the shape layer, we're going to say, hey, shape layer, the shape you're going to describe is our hexagon. And then we're going to mask our layer with that shape layer.
And why set the background color? Because that's going to be the color inside.
That's going to be the fill
But that way
color.
we don't see gray on the outside.
Yeah, you
That
won't
mask.
see gray all the way around. What you're going to see is a gray hexagon on the screen. So, and then what we do down here is we say, hey,
Wait.
if our bounds, what?
Go back on line 56 there. You're returning a type of ID or something? Or dash ID? What is ID exactly?
So ID is like, that's Java Lang object.
Okay.
ID is Java Lang object. It is it stands for any Objective-C type. The nice thing about ID versus Java Lang object though is you can assign anything of type ID to another parameter without a cast, which makes it nice. Because unlike with Java Lang object where you have to cast it to string or whatever, if it's type ID, the compiler is going to say, I'm pretty sure you know what you're doing here, so I'm just going to go ahead and allow this. But if you try and send messages that it doesn't understand, well, the
You
default
won't even see it.
implementation is actually it'll throw a runtime exception. In really old versions of Objective-C, it would just ignore them. In newer versions, it throws an exception so that you know, hey, you made a mistake here. So, then the only other thing we're going to do here is we're going to say, hey, if the size of our rectangle of this view changes, we're going to go recompute our path. We're going to re-rotate it if we need to, and then we're going to reapply it as our shape layer. We wanted to take our hexagon and make it from 50 by 50 to 100 by 100. This would get called, and it would then redo the math for a radius of 50 instead of a radius of 25.
So does that get called when you do pinch zooming?
That does not get called when you get pinch zooming, because what pinch zooming is really doing under the covers is stuff with like this type of stuff. It's just scaling and rotating and applying transforms, and it's doing it all on the
But as
GPU,
far
so it's
as-
lightning
as far
fast
as
and
your
buttery
code's
smooth.
concerned, the hex is still the same size.
Yeah. The hex is still 50 by 50
You're
hex.
just zooming into it.
You're just doing stuff with it.
Gotcha.
So, and then am I on my new one or my old one?
Kind of makes me want to go back and do.
Okay, so if you just want to look here, now we're going to replace our square view with a tile. So go back to hex game view,
What do you call it?
So you're going to come up here to the top and we're going to say pound import hex tile. Change our square view to a hex tile. And then we got to get rid of most of this stuff. Yeah, just paste in that line. We use our new class method. Get rid of all the layer border stuff. And change those like that. Bada bing, bada boom, we're done.
Yeah, hang tight. CG rect. Make a frame.
Yeah, you're gonna make a point, CG point make. Direct.
Am I not reading?
Oh, sorry. Oh, you're looking right there. Yeah. CG rec make 00 50 50. Which we're doing 00 because this is gonna get called, and then that's where we actually set the center of it and say, hey, go in the middle.
Ready to run?
I believe so. Let me just check the other project really quick. I don't think there were any other changes. Nope, there weren't. So yeah, so now we're ready to run.
Three pointy side of hex.
And if you want to play around, you can go back into that hex game view and change hex tile type point up to flat, or whatever I called the other one, and it will be a flat top. But yeah, I see the same thing. And now we can zoom in on it. And it gets bigger. So it's the exact same thing we had before, except for now instead of a blue square, it's one of our actual tiles that we're going to use.
What was the first line of code that we touched on the second version with the with frame CG rec? Because I'm having a hard time fixing that. So can't find
So just get rid of square view. Yeah. So what you need to do is change UI view to hex tile. Change square view to tile.
square view to tile.
Yeah. And change the type of it from UI view to hex tile.
Okay.
See what it says UI view right there. Change that to hex tile. There you go.
0, 0, 50.
Okay. I don't need the
And then
Added it.
tile right here.
oh, you need that, right? Yeah, tile. You go over there.
Uh,
And then get rid of those three lines there. Those three. Okay. And then change that from square view to tile.
Frame
Right
for
there.
view will be different than square view.
Change that ID parameter to hex tile type. And then get rid of your space there. It's not auto-completing for some reason.
Okay.
the first line that I put in.
Oh,
it's good
What
stuff.
could I have done? I just couldn't be.
Too many things.
It wasn't there last time.
Maybe your computer's having a hard time.
Affine transform. No.
I wasn't auto completing on the first.
Not quite right.
That's what I saw.
No, that's exactly what he
That's
said.
what I'm seeing.
That's what you're seeing?
Yeah.
I don't know.
Okay, so you two are messed up in the same way.
Yeah.
That's
Right.
That first line that we put in.
Oh, that's because you put this stuff.
That's what I was worried about. First
I'm
line
using an iPhone
code that
5.
we put in. The second version I put it in the wrong place. I couldn't find it.
That's
Oh, big piece was in the wrong place.
Yeah, the big piece needs to go in the .m file.
This is going to take a little bit. Oh, no.
Something else.
But yours turned out?
Same one. That's fine.
Oh,
What in the world?
I don't know.
Yours and Bruce's both look like a splat on the screen. Are you following? Yeah, all that caught up. So I'm gonna watch it again later and try and do it again.
What?
Any ideas?
Okay.
I'm seeing that exact same thing.
Scott, do you want to help him? He needs to let him copy it off of your hextile.h. You'll write where this hextile.h with the stuff that needs to go in the bundle.
Okay. Each is
180. Try it again.
Yeah, I have the same bug. Where am I?
Degrees to radians. That's 180. Should be a hexagon.
Hey, look at that.
Woo! Yeah!
Yours ran already.
There we go.
First time is takes forever.
Bruce, I know you like your old computer time, my friend.
Yeah, isn't Jim's laying around here somewhere?
It's an extra something that isn't amazing.
The speed will more than make up for it. Plus, you can do the scaled resolution like Scott does, so you get just as much or more screen real estate than you have on that.
I don't even miss it.
You just have to wear reading glasses, Bruce.
I know. Like I'm both near and farsighted now.
Yeah, you need to go get your LASIK done. They do one.
Yeah, I'm
One
tempted.
each eye?
actually. It's $5,000. So much money.
For what?
See, I did mine. I did mine when I worked for Next Page, and I did a cafeteria plan. My eye doctor was charging like $3,500 for both eyes, $4,000. But I did mine with the cafeteria plan, so it was great because I just told him, sign me up for $5,000, $4,000 for eye surgery, and then there's $1,000 for something else I needed done. And then the money was available immediately to pay for it, and then I just kept paying for it through the year. So
Nice.
that was nice. It's
That
one,
works
one of the
for
few
that
things
type
I think a cafeteria plan is actually good for.
There's also a little thing called a credit card.
Yeah.
There is a little thing called a credit card. Yep.
I don't, however, happen to have a $5,000 one.
Really?
No, I've never allowed us to upgrade from our original $1,200 when we got married.
I think it's actually good for your credit score to have.
That's awesome. We want to raise your credits. No, not that. Just leave it at 1,200, please. Thank you very much.
I don't need that kind of
Let me
responsibility.
just send it to you.
Yeah, just have
Kind
an
of temptation.
email it to them.
But on the bright side, if someone's got a credit card,
Yeah, well, up to 100, I guess.
All right. Well, Matt is doing that. I'm going to go open up version 3. Which one am I on right now?
All right.
I am on Hex Original. Okay, so let's go close this project. I'm gonna go email people what we need for the version 3. Open. Hex versions. Hex version 3. All right, this is when we're gonna get into the fun stuff. So our biggest changes are going to be inside of Hex Game View. So we'll just have people copy this and I'll talk about it a little bit. All right, so let's go mail this to stand up. All right, now don't make the mistake that Matt made last time and stick what I just gave in the .h file. This needs to go into Hex M. Just select pretty much everything in there sit wholesale with what I just emailed you.
Anybody else noticing that?
Yeah, I've been
Are you guys on like shop.net?
having some slides.
I'm not shouting that.
All right,
This is hexgameview.m.
hexgameview.m. Just start at that import line, just and then go down to the end, and then just replace wholesale. I send over. Oh, and we're going to need some properties in the .h file too. So let's go grab those. These ones you could maybe type in, maybe not.
Just email.
I'll just email.
Uh,
Okay, so you're going to stick this in the center of your implementation or your interface. Oops. Stand up. GameView.h. All right. So copy those. Go over here. And you're going to stick what I just emailed you, the smaller one. You're going to stick it right in there.
what about
Okay.
the first one, the M, where we stick the big chunk?
In the .m in the hexgameview.m file.
Where in that file? Does it matter? Top.
You're gonna go into there, and you're gonna start right here, and select everything down, and replace the whole darn thing. Okay. Hex tile. The only other thing you need to do in hexgameview.h is you need to import hextile.h because we're now using our hex tile type inside of there.
Because I've been looking for this little hash import.
So that you go up here and type import hex tile. Oops. There you go. You're happy again. All right. Has everybody got those things cut and pasted?
Yeah.
Almost. Okay.
So I need to import hex tile?
Yeah. The one thing I forgot. Sorry. In hexgameview.h, go right up underneath UI kit and say import hextile.h, and that will clear up your little red thingies on the
Still
.h file.
one error though.
in the side of the .m.
In the end, yeah.
Let's go see what it is. Oh yes, because there is one more modification. So go in the hextile.h, and we're going to add a new property. That property, this is a non-atomic. Since it's going to be a string, we need to say it's strong, so it keeps a reference. And a string ID. This is to hold our tile ID.
Go back.
And that will get-
What are we doing?
So
Hextile.
hextile.h. So we go to hextile.h. Right underneath the property declaration for hextile type, we're going to say property non-atomic strong NS string pointer ID.
Now, pointer ID is simply a name. Why are you calling it ID?
I could have called it tile ID.
Okay. I just want to make certain. I hate that word because it's also a type.
It is also a type.
Can you
With-
do a refactor here and rename it everywhere?
I wanted to do that.
I'm not like missing something.
I really like what you did with the tile idea. Steal that. Take the A char plus a row to get
Yeah.
that. That's much better.
What? Requires a symbol such as a class, a function, or a local variable. No, I guess it won't let me rename the property. But you could have called it tile ID if you want.
Okay. I just
There's a different namespace in Objective-C for variables and for types and for keywords. So you can actually use a keyword as a variable name as long as it's not ambiguous, basically. As long as the compiler can resolve it, then you can do it. And in this case, it can. So. All right, so let's go talk about hextile, not hextile, sorry. Go to hexgameview.m and let's talk about what we're going to do here. So we've added some properties over here that are going to be set by our game view controller. We'll take care of that in a minute. We've got our board size. We have a tile radius. We have a hex tile type. So what kind of game board we want to lay out?
Meaning up or
flat, right? I did not have the code in there for the flat. I only have the code in there for the up. And then we have this. So we're going to introduce some block syntax here. This is a new type of property, non-atomic copy.
What does that mean?
So copy means when you assign to it, it's not just going to take that thing, it's going to make a copy of it.
clone.
A clone, yep. And so anything you assign to that needs to implement the interface. It's kind of like serializable, but it's called NS coding.
And that's what?
NS coding.
CODING.
Yeah, why they called it coding instead of copying, I have no idea. Don't ask me, but it's called NS coding. And it gives you the ability to, anything that implements that property, you can make a clone of it using
we went
copy.
down the Swift route. It's more modern. These names might be different. I think they mimic.
Swift doesn't have some of these conventions, but a lot of what you're doing in Swift is inheriting from things that are still written in Objective-C. So some of the names remain the same. I don't know if some of the same rules apply, like if you're going to make a copy of an
It's my
object.
understanding that Swift has its own core library that does a lot of this low-level stuff.
And it probably does. So, so we're saying, so that copy keyword just says when you assign to this, I'm going to make a copy of whatever you pass into me, which is important if it's a block, because this block is a closure, and closures initially exist only on the stack. And then once you make a copy of them, it moves them transparently underneath the covers to the heap and turns them into a reference count object. So if you have a block that you're just passing around and you don't ever save it off for later use, it actually just stays on the stack until the system determines that if this thing stays on the stack, then it's going to be deallocated, at which point it also transparently moves it to the heap. So, and then this is just, all we're doing is, this is a convenience method for this, right? Because a property, basically, it's just like Java. You say, if you have getters and setters, saying property implicitly means there's a getter. Unlike Java, it doesn't have a get in front of it. It's just called tile tapped handler. The getter is going to be called tile tapped handler. And the setter is the name of the property with set appended, and then it recases the name just like Java. Set tile tapped handler. And so having this allows us later on in the code, if we want to set a tile tapped handler, it will then fill this in with the method signature, and then when you hit enter, then it takes you right directly in to start writing the code, and you don't have to re-enter the signature, and you'll have the variable name.
What indicates it's blocked? The caret?
The caret.
Yeah.
So if you see a caret like that, rather than being a function pointer, it is a block or a closure or a lambda or whatever you like to call it. Choose your nomenclature of choice.
And this is just so we have a callback.
Yeah, this is a way to do a callback without passing references and things
Does
around.
this make any sense?
It is.
So it's very similar to like the callbacks that we do in the HTML5 app, that when we have pass the callbacks into the bridge, and then they get called back later. It's the same type of thing, just they had to do a slightly funky syntax because it has to fit into the C world, the C and C++ world.
I can't wait to use Swift.
Yeah, Swift just, I
His name.
don't think it has a caret. You just open bracket, close bracket. Yeah. So, so then we have a couple of just parameters, or not parameters, instance variables. We're going to save off the current bounds of our hex game view. That's going to allow us to know when we need to recalculate. If our bounds change, we need to relay out our grid, redraw our paths and stuff. An NS mutable array is just like an NS array, but so I remember when we talked about Objective-C, some of them, there's mutable objects and there's immutable objects. The normal versions are all immutable. So once you create an array, it's immutable. You can't add things to it. You can't remove stuff from it. You can't change anything, which makes it great for thread safety. If you want a mutable variant, then you use the mutable keyword. So it's an NS mutable array for our tiles. A Boolean value that tells us if our layout has changed, which we're going to set down here in our bounds. And then floats that represent our tile width and our tile height. So we now have an awake from nib in here. What we do in that is we just say, hey, grab our current bounds so we'll know when they change. We have a set, we're overriding the set bounds call from our parent UI view. We call the super method, then we say, hey, our current bounds and our regular bounds, are these things equal, yes or no? If they're no, then we say our layout's changed, and we'll know that next time we need to relay out our stuff. Calculate board values. This is a method that Scott had, so we don't have to just have this math all over the place. We calculate it once, depending on if we're flat side up or pointy side up. We calculate our tile width and our tile height. Since we're doing point side up, we'll talk about those. Our tile height, because our points, our vertices are now vertical. Our widest points are now vertical instead of horizontal, right? When we were flat side up, we had these two vertices on the either side of the square, and that was our widest point, and so that was going to be our width, and it's half of the radius, or radius times 2, I guess. And then now that we've flipped everything, our tallest things are in the height area, so we're tile radius times 2 is going to be our height, and our width is the square root of 3 divided by 2 times the tile height. And if you want to know why that is, then go read the math that's in Scott's project that we both used. But that's it. That's geometry. So, all right. So let's get to the layout. Layout subviews down here. It's the same thing we were doing before, only this time we're going to say, hey, if we don't have any tiles, or if our layout has changed because our bounds has gotten bigger or smaller or something, then we're going to do this layout tiles thing again.
And so the super function we're overriding, layout subviews, is their paint method. It's called whenever the view needs to paint itself.
No, this is the actual paint method down here. But we don't have to implement it because we're not actually doing any custom drawing. Right. We're doing all these other things. When is
layout subviews called?
Layout subviews is called anytime the view needs to be relayed out, which is triggered by when the bounds change. Or if you want to force it, you can say set needs layout. You can tell any view, hey, you might not know that you need to be laid out again, but I just did something and you need to lay yourself out again. And that would also force it to be called. So let's go to layout tiles. So the first thing we're going to do is we loop over our tile array and we say we're going to remove all the tiles from their super view. Now you say, well, we haven't created a tile array yet. Well, that's because we're using Objective-C, and it's great because we don't have to worry about, say, hey, if tiles is null, then don't do this. We just say, hey, iterate through everything in tiles, and if it's nil, then it says, okay, well, there actually isn't a tile array, so it just becomes, that whole little block becomes a no-op. But if there is something in it, it'll go through each tile, we'll grab it out, and then we'll remove it from its super view so that we don't get a memory leak every time we relay out. Then we recreate our tile array right here. We create an NS mutable array. The capacity is board size times board size, right? So it's 5 by 5. We're going to end up with 25 tiles that are arranged in our pattern. Then we say we're going to calculate our board values so we don't have to have the geometry math everywhere. And I probably could have put some other things in there. Maybe I should, but anyway, this is what I got to. Start X. So this one was a little challenging to figure out. The size of our board, since it's a rhombus, but it's not like an actual like a regular square, it's like a slanty square, right? And so the actual size of our board is actually the size of the board minus 1 times the tile width. Okay? And if you don't believe me, once we get our little grid set up, you can actually go count and say, because each row of tiles as we lay them out is going to be half a radius apart, right? Half a width apart.
By the time you go down,
and so by the time you go down on a diagonal from the top to the bottom, it's not actually 5 widths apart, it's only 4. So it's funky, and I'm like, the only reason I'm doing this is so it's centered in the view, and it took me a while to figure it out. And then since we're starting, so we have our rhombus here, right? We're starting not at half the size. We're starting at a quarter. We're going to center, and then we're going a quarter of the way out because we're going to lay the first one out, and then we're going to drop down and move over, and then lay that out and drop down and move over and drop down, move over, drop down, move over, right? So, so if you wanted to actually say what the board width was, it would be board size minus 1 times tile width. The height, since we're doing pointy side up, is actually a lot easier. It's just board size times tile height times 0.075.
What's that matching number? 5.75.
0.075. It's just the spacing between each one of our rows, since we're pointy side up, is 3/4 of the 3/4 of a width or a height. 3/4 of a height.
We divide by 2 to get the center.
Yep. Divide by 2 to get the center. Done. All right. So now we're going to start our 2 for loops. We have our row for loop and our column for loop. Now this line is the exact same line we had before, other than we're not just hard coding a thing in here. This tile radius is going to be set by our game view controller, and so we're going to say, hey, the frame of this is going to be 0, 0. Obviously, it's not really 0, 0. We're going to set the center later, but it's 0, 0. It's tile radius times 2 and tile radius times 2. The ID is we're going to do a C trick here, and we're just using the A as a character, which is also an integer, and so you can do addition with it. And so if you say A plus 0, it gives you an A. If you say A plus 1, it gives you a B. If you do A plus 3, it gives you a C.
Oh, I love C.
So
I can do that same thing.
Yeah.
Rewrite that way that I made, and that's it.
So it just makes it an easier way to give us an A1, A2, A3 chess type of thing, right? Rather than I also thought about using index sets. Objective-C has the concept of an index, or not an index set, an index path that stores basically how you walk through a multi-dimensional array to get to a certain object. But I thought this would be more readable in the long run, so we use that.
And that's where the tile's going to be on the board.
So that's just that's its conceptual name. A1 is the top left, and E5 is the bottom right. But it's in a rhombus weird shape. So anyway, then we set the center. Since we're laying out a column here, so think of it in 2-dimensional space. We have our rows and we have our columns, right? So this outer loop is we're going to go row, 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 and then we're going to move down, and then we're going to go the second row and the third row. So the column is we're laying out along that row the first one, the second one, the third one, the fourth one. And so the only thing that's changing there is our start X parameter, which is its tile width times the column apart from the next one. Because we're doing pointy side up, it's 1 full width along, okay? And then this is how we're going to be able to tell. We'll talk more about this in a little bit, but this is our gesture recognizers. So when you tap on that hexagon, this will be called. So we add the gesture recognizer to our view. We add our subview to the game view, and then we add the tile object to our list of tiles. We actually don't need the list of tiles right now, but I'm assuming we're probably going to want it at some point, so that's why we're saving it off. So,
Start playing the game.
yeah, once we start playing game, we're going to want to do stuff with it. So, and then once we've laid out all the columns on that one row, then we're going to move down. In order to move down, we say, okay, our Y has to go down tile height times 0.075 because we're pointy side up. If we were flat side, we would actually be going down a full height. Okay. Start X is also going to move, and it's going to go by half a width, aka the radius. Right? Yeah. So we could have right there. We could have just said radius.
I get it, because the tip fits into the bottom of the other one. So you moved over half, you're 3/4 of the way down. You're not all the way down. They put together.
Yep.
I get it.
So
You'd have to change those numbers if you're doing flat.
yeah, if you're doing flat, you change the numbers a little bit, which is what we were trying to do last week. But we didn't. I think if we would have used the math that Scott found the second time, we all could have probably figured it out right then. But yeah, the other math was too confusing. It didn't really explain in geometrical terms what was really happening. It was using magic numbers and crap, you know. So anyway, and then our tile tapped handler, or our tile tap method that we set right here. So a tap gesture recognizer, there's a whole slew of them: pinch, swipe, tap, double tap, you know, blah blah blah, right? You can do just about any gesture you can think to recognize, you can do with a gesture recognizer. So we're using a tap one. It defaults to one touch, one tap. We say the target, aka the class that's going to have the method you're going to call is ourself. The method you're going to call or the message you're going to send is tile tapped. So down here in the tile tap message, we say, hey, if we have a tile tapped handler block, we're going to call that block just like a method, boom, and we're going to pass in. So a gesture recognizer is attached to a view. We're going to pass in the view that it was attached to. Okay, so last thing that we need to do in order to make this work is we need to go into Hex Game View Controller, and we need to set, oh, I'm not on the right project. So we're going to need to pull a few things over. And I will, I guess, email these to you guys. Yeah, it's 4:15. Holy crap.
Gotten this beverage. Jeez.
I know, seriously. Let me just email this to you really quick. Stand up. Game View Controller 3.
This is going in Hex Game View Controller.m, yes?
Yes, .m. That's going to go right underneath the scroll view minimum and maximum zoom scale stuff. So you're going to, I just emailed it to you. You're going to go into Hex Game View Controller.m and you're going to stick it right there. Oh, and you're going to need those other files that I went and created. Android or iOS doesn't have a toast like Scott did in Android. So I created one. Let me send those files really quick. Show in Finder.
I don't feel like I'm in the right place. Hex Game View Controller.
Because these are the files he hasn't sent to us yet. It's about to.
All right. You're going to want to take these and just stick them straight in your project underneath the engine folder. SH toast.
SH is your namespace. What is SH?
Shout hex.
Shout heads. And that's just another file.
Yeah, you're going to just take those, just
Save in the directory or?
yeah, just in your email. Just grab them from your email and just drag and drop them right under the engine thing. So
Their UI views subclass for the SH2.
they are UI views. Or yeah, SH toast is a UI view. That's a UI view subclass. So I'm going to do a similar thing, but I'm just going to grab them from here. Then I'm going to switch to this one.
They go in Engine?
And then, yep, I'm just going to
It's the
drag
first
them
thing I have
into
in
engine. Yeah, it is. It's the only thing you're going to have in engine right now, just because,
Copy items if needed.
yes, copy items if needed. So you should, once you drag them from mail, you should have something that looks like this. Copy items if needed, added folders, create groups, add to targets hex should be checked, hit finish. And then in Hex Game View Controller, to make that last thing go away, just say pound import sh. And
That's in the dot.
in the .m. Yeah. And then assuming that everything worked.
Mine didn't. Game view is not resolving. Even though it's synthesized.
How did you drag those files into?
Oh, sorry. That one more thing. So in here you need to pound import hex gameview.h and then change the type of our outlet, because when we made our outlet it wasn't a game view. We're going to change the type of the outlet to hex game view. And once you do that, all your little red things will go away, life will be happy,
Yep, that worked.
and you should be able to build. And then once we build and run,
Build succeeded.
once we build and run, you'll notice that we have our little grid.
Wow.
Now,
Some of the lines aren't showing up.
yeah, well, we haven't drawn a border around them or anything yet. So, so they're there faintly. They're just really faint. So
Okay, I think that's just a
Drawing.
it's a drawing artifact. I mean, there's not really a border there. It's just the way it's being blended. All right. So now, can anyone tell me the problem that we're going to have potentially with these tapped handlers?
I don't know, but I did it. I got it broke
Oh,
for
I
me.
know, but should I not say?
No, go ahead. If no one else knows,
Well, because your shape is still a square, right? So you could be clicking outside.
and because it's a square, we have actually a whole bunch of overlapping squares, right? So that is a problem, especially if you were to zoom in on these. That tappable area becomes much larger because you're scaling it up, and you could actually tap on something and it would be the wrong area. So in order to fix that, we're going to use something that I think is just super cool because it's really easy. All we're going to do is we're going to override a new method. Or maybe we already did. Did we already do this? Because I just had you copy hex tile over.
Oh, you didn't have to implement your own point and rect. They just have one.
No. So, oh, no. Okay, good. Yeah, we got to do this. Okay. So we're going to implement a new method in here. Inside of hex tile. Boolean method. We're going to override it. It's called point inside. Point inside is a super fun method. All it does is that you return true or yes if the point is inside your view, and you return no if it's not. And the default just uses your rectangle and goes on its merry way. Well, we're not a rectangle, we're a shape. But since we are a shape, we have a path, and since that path is a closed subpath, all we have to do is say return path contains point. And then all of a sudden, bada bing, bada boom. Now, if you click on any of the overlapping areas, it'll say, hey, that point's not inside my actual view.
Where did point come from?
It's being passed in. So the system takes wherever your touch is on the screen, the system takes that touch, it translates it into your local coordinates for your view, and then you just compare it against your path and say, hey, is the point inside my path? Yes, it is. No, it's not. And away it goes.
So run it again.
Yeah, I mean, you're not going to be able to tell unless you're on the device and you're zooming in.
Okay, so when I click it, it breaks, and it stops me at a break.
You don't get this?
I do get that. When I tap on it, I get it. It breaks in the debugger
Wait, when you tap on what?
on any cell.
Oh, that's what I said. When you tap on the cell, you don't see this little thing at the bottom?
No, I see
Okay,
it.
then something happened.
Yeah, here's the error. Clicked it, and this showed up.
could not load nib and bundle
in the wrong place.
sh toast. Yeah, maybe your nib did get loaded. Go here. Click on engine. Yeah, you forgot the XIB file. So you need to copy the XIB file over too, and then you'll get the toast. You get the toast?
You're right. I missed
Yeah.
it.
Okay.
What is the next thing?
Oh, does it rotate automatically?
Yeah.
Ain't it cool? I didn't even know it did that. I hadn't rotated it yet. So
Scott, any question?
It's just it's the layout version.
so what's up?
I'm just asking with the XIB, but it's just the layout file.
Yeah, that's just the layout file. All I did was I took what your Android toast kind of looked like, and I just said, okay, black background, 75% transparent, put a label on top of it, and then when you assign the message, I say, hey, system, tell me what size that thing should be with that string. You know, make sure it has 10 points of padding on top and bottom, 20 on the sides, and then show it. So that's a re-implementation of Android.toast in like the interface builder file in like 20 lines of code. So hey, you can go look at it if you want.
There
It
appears to be some error.
just says,
Just small, or maybe it's just my mouse. So I click there and it works, right? If I click there, it's not inside. I'm inside. Okay, didn't work a minute ago. Let's get a bit closer.
see you're just barely outside or right on the line.
Okay.
It has to be inside the point. That path method, if you're right on the line,
Because we're leaving a little space between it, right? Just barely.
well, there is no space between it, but if you click right on the line, that's not technically inside the point.
Okay, that's fine.
Right? So it's going to be, so technically it has to be inside the whatever. You know. It's not tennis, so if you're on the line, it's not in. It's out.
All right, so that's it, right?
So the only other thing I have done is the sound stuff. We could sit here and do that if you want. It's just a couple lines of code.
Let's go. I mean, we're here.
Okay.
Let's get
So,
to the spot.
The thing I hadn't done yet that I didn't have time to adapt was coloring the outsides of the thing. And so what I'll do is I'll check that in. I've checked all these other versions into Bazaar. Once I have that figured out, I'll check that plus the sound stuff into Bazaar, so you can go look at the differences and what I did to make that happen. But again, it was another one of those things I was like, well, I'll just copy what Scott did, and as soon as I did that, I was like, well, I'm not drawing here. I don't really need to draw here. You know, I can just, and so I didn't have time to adapt it. So, all right. So the other thing we're going to do is, let me email you a sound file really quick. So we didn't do a sound manager because once we have background sound, maybe we'll introduce something like that. But for sound effects in a game, you actually just use this really simple system API. The only difficulty with it is your sound files have to be in a certain format, which is called a CAF format, core audio file format.
Right, it doesn't play waves or MP3s.
Yep.
That you can convert pretty much anything to CAF, right?
You can really easily. You just have to do it. There's like a command line thing. So I converted it for you. I'm not going to make you go through that. So here it is. Here's the CAF file.
You created that XIV file? Or was that you just dropped it?
The XIB file, you just drop it in the engine, yeah.
Where do we put the sound file?
Okay, so the sound file, you're going to go, let me grab it off my desktop. So I'm dragging it from my email, and I just, so I'm just going to drop it here for a second, and say add to target hex, and then I'm going to say finish. Yeah, and then I'm going to go here, and I'm going to create a new group called sounds, and I'm just going to move it into there. If you need to save it to your desktop or your downloads folder or something, then drag it over. All right, so once it's there, then let me see here. We go to, we're going to go into the Hex Game View Controller, and we're going to do a couple things. We're going to add this statement right here. So you're going to import a new framework called Audio Toolbox. So go into Hex Game View Controller.m, just below your includes, paste in or type in @import Audio Toolbox. Cool thing about @import, it replaces a bunch of steps in Xcode where you used to have to do a pound import and then you had to go in and link everything. This makes use of the Objective-C modules, which is very similar to packages and jars and stuff in Java. But even better than that, even better than, with jars, you still have to make sure they're on your compile path and your include path. When you say import, it modifies your project file and does everything so that all you have to do in order to use Audio Toolbox is say add import and you're done. You don't have to tell it to link with anything or do anything other fancy stuff. It's just one statement and it does it for you. So it's kind of nice. And then we're going to go create a new variable called System Sound ID. And so we're going to go down here. So you're going to go to where it says UI scroll view delegate, go to the end of that line and hit a return and put some square brackets. You're going to paste in there. Yeah, curly brackets, sorry. Curly braces.
So that means we're adding something to this interface.
Yeah, we're adding a member variable, instance variable. So it's called, the type name is System Sound ID. It's going to be our click ID. And then we're going to use this little piece of code here inside our view-did-load method. So scroll down a little bit to view-did-load. Go to where that comment is and start typing there. So you're going to do NSURL sound URL. We're going to load it from our application bundle. So you say NS bundle main bundle, and you say give me the URL for the resource named click that has the extension CAF, aka this file right here. And then once we've done that, we're going to say, hey, audio services, create me a system sound ID. Don't type in all this stuff. Just put in sound URL and put in the click ID the way it's typed, and then it will tell you it's an error and it will allow you to fix it. So you don't have to type this stuff in.
URL for resource, capital URL.
Capital URL. It should auto-complete it for you.
What am I not supposed to type?
Down here, just type in sound URL. Don't worry about all the stuff in front of it. This stuff is because of ARC, automatic reference counting. So just type audio services, create system sound ID, open paren, sound URL, comma, ampersand click ID. Like this. Audio services, create system sound ID. Type in sound URL, and then you're passing as a reference your click ID. Click ID. The compiler is going to complain and say, hey, you can't do that with ARC. And then you just say, fix it, use _bridge to convert directly, no change in ownership.
So my
Well, when you compile, if it's not already.
Can I like turn off auto compile?
I don't know.
Unused variable status.
Maybe.
Trap.
And then you say, if status is non-zero, then you say, hey, could not load the sound. It shouldn't happen, so you don't necessarily need to do that if you don't want to, but
Error handling.
It's error handling, and it will tell you in case you type the name wrong or something.
Oh. Process unused variable status.
Yeah, that's because you say if status. You need to put the if underneath it. So.
Sound.
And then. Tell me when I can switch away. We got one more thing to stick in there.
I can't see your log cover part of
Oh,
that.
it says slog could not load click sound. It's an sprintf statement. Could not load click sound %d and then pass in status. So it will just tell you the integer code if there's some problem with it. And
Dude who invented Next is like got a big old smile on his face for about a decade now.
Well, Objective-C existed before the Hex.
Really?
okay, then we're going to do a couple of fun things here. We're going to add a play click method.
In fact, I think Objective-C written by a guy who used Simula or something. I was forced to use C. They wrote a processor for C that turned it into.
Second.
All right. So you're going to add a method up here at the top to get the actual sound to work. You're going to add a method at the top called play click.
It's got to be something. It's just I can't find it. Okay, wait, where did play click go?
So you're going to add up underneath your properties in Hex Game View Controller. Underneath Hex Game View, you're going to add a void method called play click. So this line right here. And then down in your tile tapped handler where we show the toast, we're also going to there play the click. So that line, myself, play click. So the reason why we're doing this is we don't want to capture a strong reference to ourself inside this block because it will create a retain cycle, aka a memory leak. And so we declare the myself variable to be a weak version of ourself so that it doesn't create a strong reference. So we sell myself.playClick, and then the playClick method is just this.
And so the way that you made this as a private method is you didn't put it in the H file, it's just defined in the M file.
Yep.
All right, well.
So then just go add the playClick method there. And once that is done, you'll notice that when I tap on my screen now, I hear a click, 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 click.
No doubt. Guys, may I interrupt just real quick?
It's Darrell, no.
Is Dave still on the line?
I think so. I haven't heard from him in forever. Dave, are you still there?
I'm here, part of Solidarity.
Thank
Okay.
you. All right, Dave and Joseph. Darrell just did a demo for someone overseas trying to show the linking. Went through the whole schmear and he says it didn't work. So since it just happened, could you guys try and help me identify what happened? Darrell, please tell me your exact use case and I'll relay it in real time to them.
I created a flash code called I created it and sent a copy of it to myself.
Hold on now. You're using our production app, not the test flight build we sent out, right?
No, this is a test flight build.
Well, that's not. Well, is that
Which
point?
test flight build do you
If it
use?
isn't a very recent one, we weren't pointing at production. We were pointing at staging. We only went to production about 2 hours ago, 3 hours ago, and that's why.
Okay, that's the problem.
That is the
Okay,
problem.
well, we just identified the problem.
Okay.
Well, in the meantime, can somebody go do what we did before and just go cherry rig it? We're going to do this demo tomorrow, and if I can show her showing up in there,
Just tell them to go download the
it'll be the same effect.
Tell them to go download the most recent one and test it.
He's talking about
I
putting that.
will do that, but it's too late now. I can't go re-sign her up, so it
Oh.
won't stay.
She signed up. So she signed up in production. Dave, can you create an artificial link between Darl in production and this new lady, and her name is?
Reem, R-E-E-M, as in Mary.
Did you hear that, Dave?
Reem as in Marion, a installation link? Yes.
Her name is
R-E-E-M.
R-E-E-M. She signed up in production on FlashVote. Put her under Darl for me.
I will make a link.
Thank you.
And if he's talking about the links
That's
of
great. So that's
Joseph,
what I'm going to see tomorrow. She's going to go sign up some other people, and then presumably if it's working, then it'll show the connection down
from my use of Joseph's app, it takes a little bit for it to update when I sign someone up. So if I go sign someone up, it's
So
like
it doesn't happen in real time then.
not what I've seen. I've signed up someone.
I'm going to use it.
Took a little bit. In Branch, it updates immediately, but on Joseph's app, it took like 15, 20 minutes to refresh.
It's talking to our server, not to Branch's server.
So it's an update because when I signed up 4 people in the coffee shop, it didn't show them underneath.
But do you talk to the server or do you read it on your phone?
I read the document.
So maybe it's just we need to increase the cron job.
It didn't happen.
Would Dave do?
That's it.
Hey, Dave, the document that updates the people.
Plaza Hotel.
We can we increase the regeneration of that so it regens every 2 or 3 minutes instead of every 15 minutes or whatever?
Hold on, let me show you.
Which list of people?
Matt, which list would it be? Joseph will send you the document he's calling.
Yeah.
Let's set it to every. Well, if we know he has demos, do it every 30 seconds.
Yeah, let's do it let's just do it fast.
Let's see. That is.
Have we tested this since we did yesterday?
We should probably test it.
This morning or whatever.
Joseph and Dave, do you have time before we call it a day today for you guys to do a test that this linking stuff is still working? Could I ask you two to do that before you call it a day?
Sure.
Apologize.
What does linking mean? Attribution?
Yes,
Yeah, the
attribution.
Get for type.
Okay. And that all those records are instantly updated anytime anything happens. So I'm not sure what document you're talking about.
Maybe
Okay.
It was just a weird instance.
All right, well. All right, thanks, guys. I'll stop interrupting. There are. So they're going to verify.
All right, so that's pretty much
If I already have
Hex.
persons, I don't get them again. If I've already got your information for that, I don't go to the server again. So I don't refresh that data unless you
Yeah.
refresh.
That's good.
I like logging in. I signed up someone to Branch, and I went to your app. All right. What was that girl's name again?
Now, shows this. It's just loading.
All right,
Production.
ending the broadcast. Thanks for joining us for Shout University.